Greetings, 6th grade parents and students. Mr. Korn here. Today's video is about exponents. What is an exponent? What does it do to the base number? And how do we use it to solve math problems and perform operations? Students in 6th grade have already been partially exposed to exponents in 5th grade, but they need to reinforce this knowledge because being able to work with exponents and find the values of different exponent numbers is important to using the order of operations, solving equations, and simplifying math expressions. Let's look at this example here. This number is a 5 with a little 3 up and to the right. This little number that is above and smaller than this number here is called the exponent. Okay? And I'll explain what that means in a second. But for right now, we'll see we have two numbers. We have this number, which is the 5, and this is called the base number. This number can change. It's usually written larger in size than the exponent, and the exponent is usually written smaller in size than the base number, and it's written to the right and up a little bit. Okay? So whenever we see a number in this format, okay, we know we're working with exponents. Okay? So in this example, our base number is 5, and our little number up to the right is called the exponent, and that is a 3. So we can say this in a couple ways. We can say 5 exponent of 3, or we can say 5 to the third power. Let's see what this means. The exponent is very important. Okay? And what this tells us is that the exponent tells us how many times to use the base number in a multiplication sentence. In other words, how many times do I multiply the base number by the same number? Let's see an example. When we see a number like this with a base number and an exponent, we call this the exponent form. So when I ask for the exponent form of a number, it's simply written like this: a base number and its corresponding exponent. But then what we can do is we can expand that out into what's called expanded form. And this is truly, this form, truly the meaning of exponents. So since 5 is our base number and 3 is our exponent, what this really means is that we take the base number of 5 and we multiply 5 together 3 times. The reason we're using the number 5 in this multiplication sentence, or this expanded form, is because 5 is the base number. If the base number 4, we would have 4 times 4 times 4. But we don't. We have the base number of 5. So we use the number 5 as our main number. The exponent, which in this case happens to be 3, the exponent simply tells us how many times to use the base number in multiplication. So since the exponent is 3, that tells us that we take this base number, write it out there 3 times, and then multiply it all together. Okay? One of the most common mistakes that students make is that they add these together. Okay? And they go 5 plus 5 plus 5. This is not the case. An exponent, and you can remember it because exponent has an x in it, means to multiply the base number over and over again. And the exponent tells you how many times to multiply that base number together. Okay? Then lastly, we have a value. The value is simply what this expression or this number is equal to. So when we're working with exponents, it's sometimes helpful to multiply together in different parts. So let's take it one step at a time. So let's rewrite our number here in expanded form, and let's take it one step at a time. So our goal right now is to find the value. We know that the exponent form of this number is 5 to the third power, or 5 with an exponent of 3. When we expand it out, we use 5 times another 5 times another 5 because of that exponent of 3. But in order to find the value, we got to do some multiplication. So first we multiply these two 5's together. 5 times 5 gives us 25. But we had an exponent of 3, so we must multiply that by one more 5. So 5 times 5 is 25, times another 5, and that gives us 125. That is our value. So these three things here mean the same thing. They're just written in different forms. 5 exponent 3, or 5 to the third power, is the same as 5 times 5 times 5, which, when all said and done, has a value of 125. Okay? Let's move on to the next slide. Some common mistakes. Some common mistakes that students make. Let's use our previous example of 5 exponent 3. Some common mistakes are students will write out 5 plus 5 plus 5. This is not correct. It must be multiplication, 5 times 5 times 5. Another, and actually an even more common mistake that students make, is that when they see 5 as the base number with an exponent of 3, they think that it's simply 5 times 3. This is also not the case. Okay? 5 times 3 gives us 15, which is way different than 5 times 5 times 5, which gave us 125. So a big difference in values here. So it's important when doing exponents or practicing exponents with your student is to not let them make these mistakes. Remember, these are a multiplication problem. The exponent tells you how many times to multiply the base number together, not add or subtract. Also, 5 exponent 3 does not mean 5 times 3. Okay? It means 5 times 5 times 5. Alright, let's move on to another example. Here we have a new exponent and a new base number. This number we have here has a base number of 6 and an exponent of 4. So our exponent form, of course, is 6 to the 4th power. In expanded form, we take our base number and multiply it together 4 times because the exponent is 4. That's supposed to be a 6 there, pardon me. 6 times 6 times 6 times 6. That's 1, 2, 3, 4 6's. And I get that 4 because of my exponent. Okay? Then we must find our value, so we got to actually do a little bit of mathematics. So I'm just rewriting out my expanded form, and I'm going to take it one step at a time. Okay? 6 times 6 gives us 36. Times another 6 gives us 216. And then we got to times it by one more 6. because the exponent was 4, and that results in a value of 1,296. So we multiply 6 together, 4 times 6 times 6 times 6 times 6, we get a value of 1,296. Alright? Okay? Lastly, well, actually two things, we have some special cases. Okay? And it's important that your student know these special cases. The first special case is that anything with an exponent of 1 just equals the base number. 6 raised to the first power, well, if I wrote that out in expanded form, it would just be 1/6. 6 is my base number. The exponent tells me how many times to write it out, just one time. So 6 is just equal to 6. So therefore, any number, no matter what the base number is, if the exponent's 1, your value is just your base number. Another special case is that anything with an exponent of 0 equals the number 1. So no matter what your base number is, if your exponent is 0, there really is no expanded form for this one, and the value is just 1. Even if the base number changed to 7, or even if the base number changed to 15, if the exponent is 0, the value is 1. And there is no real expanded form for this particular special case. The last special case is when we have 1 as the base number. If 1 is the base number, the value is always 1, no matter what the exponent is. So if 1 is our base number, our value will always be 1. Because this is like saying 1 times 1 times 1 times 1, and of course I have to do a fifth one because the exponent's 5, times 1. All these 1's multiplied together stay the same. So 1 times 1 is 1. Times it by another 1 results in 1. Times that by another 1, and you get 1. And then times that by the last 1, and you still get 1. So this case does have an expanded form. It's just a bunch of 1's being multiplied together. But anytime you have 1 as the base number, you do have an expanded form, but your value is always 1. Alright? Thank you for listening. Have a great rest of your day.